an example lamp installation, what I did before. This is the back side of the lamp with the heatsink, ventilation and the boost power buck, and inside is a COB-LED. And this is a little switch that was already the original switch of the lamp, and you see how bright the COB-LED is. In this step I sketched the size and the position of the heatsink and of the DC-DC buck inverter on the back of the old lamp housing. Here I fixed the COB-LED on the heatsink. I placed a small drop of heatsink paste on the back side between the COB-LED and the heatsink to produce a better heat exchange between the aluminium plate of the COB-LED and the heatsink. So it's a bit hard to screw it. I drilled 2 holes through this heatsink and placed some 3mm bolts through it, and it clips the LED chip down onto the aluminium heatsink. Now I will place the 12-volt fan back into the heatsink. Originally these kind of heatsinks, I think they are for graphic cards or something. They sell them on eBay, and I will show you the page where you get them. And they are quite versatile for many heatsink advantages, and they are very cheap. So I think one heatsink including the ventilation is like $2, something like that. So now we will place the heatsink and the DC-DC buck inverter into the housing of the lamp. If you do this kind of work, a Dremel tool may be helpful to cut away some small edges, what is left. For the big cuts I just used a small saw and sewed it out. And now I'm positioning the 2 devices in the plastic housing. So the next step will be to use some 5-minute epoxy resin, and I will fix the heatsink to the plastic with that, with some drops only around. I will put some masking tape on the front side to fix it in the right position, and just place some small drops of epoxy resin around, wait some minutes, and it's properly fixed. The advantage of epoxy resin is it's heat resistant, so it won't melt even that it gets warm. Don't use like a glue gun or something. So glue gun, the glue will just heat up and everything will fall down. Don't use that stuff. So this is epoxy I will use. So this is the masking tape. It fixates the heatsink as long as the epoxy resin will be liquid. And you can see that I already fixed a DC-DC buck inverter with 2 small 3mm bolts to the plastic housing. So actually you see I'm working on 2 lamps at a time. So this is the electric circuit, very basic, very simple, nothing big. Just you see the 24 volts DC in, the switch, then the buck inverter, and the 24 volts is inverted into 22 volts out on the outside, and then goes into the COB-LED, what means chip on board LED. And then the 22 splits also down to the small inverter buck there, and it becomes 12 volt for the 12 volt motor of the electric van for the heatsink. So we need 2 voltages on this project. Here that's the outside of the housing. You see the shiny epoxy resin that holds the heatsink in place. This is the inside of the lamp. The wirings is placed inside the lamp, and that's a COB-LED, the DC-DC buck inverter bolted down to the housing, and we see the switch there. And from the back side we can also see the small buck inverter just down there under the heatsink that produces 12 volts for the motor. And there is the 3 screws to be seen that will hold the lamp with a distance to the cupboard over it, so that the ventilation gets air. That's the inside of the DC buck inverter, the out, and that is a small buck inverter. Actually, these LEDs are more brighter than the 20 watt halogen we used before. So we have now a really nice light in our kitchen board. So now we come to the calculations of the whole project. So it had a reason why we changed the halogen to an LED. Of course, it saves a lot of power. As you see, we had a 20 watts halogen before, divided by 24 volts, that is 0.83 amperes only for the power of the 1 bulb. So with the new COB-LED in place, it has 7 watts divided by 24 volts is 0.29 amperes only, and plus 0.1 ampere for the fan. So in total we use now around 0.4 amperes. So of course there's a little loss by the buck inverters, of course, but all in all we are, let's say, down to 50% of the energy that we used before just to power this lamp. And we have several of these lamps in our boat, and that made it necessary to save some energy with modern equipment. On the other hand, these kind of LEDs gets very warm. If we don't install a heat sink on the backside, it will die the heat death. And because we don't have much space, and the boat is also used in the tropics, so we need an active cooling with this electric van behind. And next you see, this is how I mounted this lamp. I put spacers behind, just a small insulation over the bit longer screws, and it keeps a nice distance to the cupboard overhead.